Okay, what we're going to look at today is primary productivity and secondary productivity in ecosystems. Remember that productivity is the production of energy per unit time. There's two ways that we can measure that. The first, we can measure the actual energy that's produced, and it's going to be the energy per unit area per time. So we have joules, which is our unit for energy, per meter square per year. All right, the second way that we can measure that is through biomass. So biomass is measured in grams. That's the dry weight. So it's the biomass that's added in grams per meter squared per year. Gross productivity is going to be the total gain in energy or biomass. So the energy that is produced by photosynthesis if we're looking at our primary producers, or the amount that's consumed if we're looking at our consumers. Net productivity is what is going to be left once we take respiration into account, because plants go through respiration, animals go through respiration, so they're going to use some of the energy themselves before it's passed on to the next trophic level, which is why only a small percentage of the energy that's input is passed along. All right, so we're going to take a look at primary productivity. See if I can get this where you can see it. Maybe. All right, so gross primary productivity is we look at the amount of solar energy that is actually converted to energy from photosynthesis. Only about 2% of the light energy that falls on a plant is going to be captured and turned into chemical energy or glucose. So the rest is either going to be reflected or lost as heat. So what we have here is our definition. Gross primary productivity is the gain in energy or biomass that's been fixed by photosynthesis. Now the plant itself is going to use some of that energy for respiration. So the net primary productivity is what is left that's available to the next trophic level or our primary consumers. So the way that we can calculate that, if we want to know what our net primary productivity is, it's the gross primary productivity minus the respiration. And I can rewrite this to, if I want to know what gross primary productivity is, it's net plus respiration. Okay, now the energy that is passed from our producers to our primary consumers, that's going to be gross secondary productivity. Now, when an animal eats the food, not all of it is absorbed into its body. Some of it's going to be lost as excrement or fecal matter. So we need to subtract out that fecal matter. So to figure out the gross secondary productivity, we take, we take the net, so what is passed along, and it's the food eaten minus the fecal loss gives us that gross secondary productivity. All right, so now after that consumer uses some of that for its own processes for respiration, what's available for the next trophic level, we do the same thing. It's that net secondary productivity is going to be equal to the gross minus respiration, or you can rewrite it, the gross is equal to net plus respiration. All right, so we're going to talk about in class some of the methods that we can use in a laboratory setting to determine what these numbers are. And we'll do some practice with problems as well.
To summarize productivity, you can usually assume that any of the energy that's input into the organism is gross productivity, and the output to the next trophic level is your net productivity. And then the difference is always respiration. And you could also include loss to decomposers. When we measure productivity, if we're measuring primary productivity, remember we're looking at the plants. The best way to do that is to look at the effects of photosynthesis. So we use a light and dark bottle technique because the dark bottle is not going to experience photosynthesis. So the only thing we're going to be able to measure in the dark bottle is respiration. Another way that we can do if we're looking at terrestrial is that we can remove dry and wet, because remember biomass is the dry weight, a patch, cover a second with dark plastic, because once again if it's in the dark the only thing that's going to be happening is respiration, not photosynthesis. Then you would leave the third patch as it is. and then you'll just compare the weight between the two to see what the amount of biomass created by photosynthesis is. Another way that you can do this is a radioisotope method using carbon-14 and its isotopes. Or if you assume the correlation between chlorophyll and the rate of photosynthesis, you can measure chlorophyll. The two that we're going to look at in class are the light and dark bottle technique and the patches. So we'll go into more detail about how these methods work. For measuring secondary productivity, that's our second trophic level, which are our primary consumers. You would weigh the amount of food that you're feeding your herbivore, and then after a time period you would measure whatever remaining foods. That gives you a count of how much they ate. You would measure the herbivore themselves to get the biomass, and you would also need to weigh the feces so you would know what to subtract to get your productivity. So there are things that affect the productivity of an ecosystem. When we looked at our biomes, we talked about the relative productivity and how some are more productive than others. Solar radiation is a big one. You need solar radiation for photosynthesis. And you also need ideal temperatures. So those biomes that are around the equator are going to have the highest insolation, and they're going to have warm temperatures year-round. The amount of carbon dioxide also plays a role. The amount of water, the nutrients that are present, because nutrients are limiting factors for plants, the amount of herbivores that you have in an area that are eating those plants. So the least productive ecosystems are those that aren't going to have the warm temperatures. They're going to have the lowest amount of insulation, not a lot of water, not a lot of nutrients. So those are our deserts, our tundras. Our most productive are going to have higher temperatures, a lot of water, light, and nutrients. So our tropical areas. Our forests also have lots of water, so they're able to support the growth of the trees. They're going to be more productive than, say, our grasslands. Now, as far as oceans, temperature is the opposite. It's the cooler temperatures where you have the upwelling of the nutrients from the ocean floor. The more nutrients you have, the more plant growth you can have, the more photosynthesis. So when we compare biomes, this one also has some of our aquatic biomes, like our estuaries, swamps. We can see how they compare. So those that are in the tropical areas, and then our forests are at the top. Then we have our grasslands, and then here at the bottom we've got open ocean, tundra, deserts.